welcome. This is a pretty new thing. We did it last month and we had just one person at the very beginning, but by the time we got 10 minutes into it, we had 3 or 4 people. So we'll see how it goes today. To jump into a little bit of background on Database Health Monitor before we jump into like the features and things. I've been working on Database Health Monitor since about 2011. Originally built the prototype back then, and it started out as me being a DBA and just having a bunch of queries that I commonly ran to tell the health of what's going on with the SQL Server database. So I started building those into an application. Well, I started out with SSRS, and then I found out that it was a little bit challenging to share what I'd built in SSRS. So I then adapted it into a Windows-based application. Through 2014 to like through 2022, I've just been continuing to grow it and add features. It was a beta for a lot of years. And in January 2022, we switched over to a paid licensing model. And at that point, I was 11 years into it. And I just realized that I can't keep contributing my time at this level without some type of a paid licensing model. So we put that together. And throughout 2022, we've continued to add new features. And some of them we're going to take a look at today. Just want to take a moment to talk about the licensing model that we have, because there's been a lot of questions about that since we changed it in the last year. If you start the Database Health Monitor application and you click on the software license link on the left side, there's a bunch of options in here on how you can get points. And what a point gives you a connection to SQL Server. If you have 20 SQL servers you need to connect to, you need 20 points. If you have 2 SQL servers, you need 2 points. There's different ways that you can get points. You can purchase the Database Health Monitor training course. That's 20 points that you get, so 20 SQL Server connections with that. That's available online through the class that we have. With that, it's $99 a year, and that is the absolute cheapest way to get Database Health Monitor connection points to be able to use for more than 1 or 2 servers. So if you've got somewhere between 1 or 2 and 20 SQL servers, that's kind of the best way to go. We also have, just to be subscribed to my newsletter, you can get one connection point, which gives you 1 server connection at that point. If you're Stedman Solutions ongoing customer, and you know that if you're getting a monthly invoice from me or a weekly invoice, depending on the work we're doing. So anyone who's a regular ongoing customer, you get unlimited connections to Database Health Monitor. Or if you've purchased any of our other training courses in the last year, and I say purchased because we give away one for free that's a ransomware course, ransomware awareness, that doesn't count for getting you points, but anything that you've bought gets you 2 server points, or mentoring or daily checkup or other products that we have like that. But if you're at the point that you don't want to play any of those gamification type options to be able to get to use Database Health Monitor, you can simply go online and purchase a license for $500 a year, or down here for $2,000 for a 5-year period. And that's unlimited connections, unlimited licensing there. So at this point, it was something I had to do at that point because I was spending so much time on it. I just didn't have the time to contribute. And now that we have some people paying for it, that gives me more time to work on Database Health Monitor and grow it over time. So right here, let's jump in and take a look. The first thing I wanted to cover on every one of these trainings, I like to cover a keyboard shortcut. And there is a blog post on stevestedman.com that talks about keyboard shortcuts. The one I want to talk about today is just the refresh key. And I'm pointing this out because when I see people train people with Database Health Monitor, I see that they don't think of this. And I know that when I'm working in my web browser, anytime I want to refresh a page, I've got the F5 key on my keyboard, and I hit that and it will refresh my browser. Same thing with Database Health Monitor. If we're looking at a page or a report, so for instance, I look at our what is active report here, and I see we have 4 connections there. If I want to refresh it and just get an update, I can just hit F5. It reloads the whole report, updating it with the most up-to-date data there. And that works on pretty much all the reports throughout Database Health Monitor. Any screen you're on, you hit F5 and it refreshes it. Also on the menu up here is a refresh button that does the exact same thing. If you're interested in other keyboard shortcuts, because I'm someone who likes to use a lot of keyboard shortcuts when I'm using Database Health Monitor. There's a bunch of them listed here on this link. If you just go to stevestedman.com and search on keyboard shortcut, you can find it. The other one I'll talk about while we're here is the backspace key. And if we're clicking around and we click from this report and then we go to that back here, and let's say we go to this blocking by hour report, and then we hit the backspace key, the backspace will take us to the previous screen that we were on. So we hit it twice there and it took us 2 reports back from where we were. The refresh and the backspace key are really the two that we're covering there. They're super handy when you're working around in Database Health Monitor. All right, so now let's get into kind of the core of what I wanted to do in today's demo. Inside of Database Health Monitor, there's an option to run, if you right click here, thing called the SQL Performance Monitor, which is something I built and added into Database Health Monitor in 2022. You can right click on any of your existing instances in Database Health Monitor and get it, then it'll prompt you for connection to your SQL Server, connect. The other, popped up on the other screen. The other way you can get to it is from the Tools menu. You can also go to Tools, SQL Performance Monitor from there. What this came from is a lot of clients I work with have hired me to monitor and watch their system when something is going on, a big event or right after a migration or sometime that they have specific concern over performance. Maybe it's the day that they announce their quarterly sale or things like that. What we do is I built this specifically to help in that environment. And the way it works, you just hit the start monitor. It's running in the background and it's updating things. Like every second, it's updating the number of connections. And I'm just connecting to my desktop here, which has some test code running on it. But it's updating the number of connections and the average CPU. And it's every second. And then it's going out, and every 30 seconds, it's looking for missing indexes. And it's every about 7 or 8 seconds, it's looking for blocking queries. Now, missing indexes, if you're familiar with like the SQL Server DMVs that give you the missing indexes, what that does is those will give you all the missing index since the server started. This does a comparison and just gives you the missing indexes that would have helped since I hit that start monitoring button. So if you have a specific pain, a specific slow spot of something that's going on in your SQL Server, well, you can use this to find the missing indexes that will help you right now. The blocking queries, well, before we get to that, we'll let it run for a minute and see if it catches anything. But what it's doing is it's going out and looking for any time that there may be a query that's blocking other queries for more than about a half second. And we know in SQL Server blocking occurs, and it's a good thing because it keeps your data consistent, but it's a bad thing because it slows things down. We'll get to the blocking queries in just a minute, but let me tell you a short story about how I used this just yesterday. Yesterday, I was working with a client. They called me, they needed desperate help about a query that was running really slow in their system. And it was an insert into a good sized table, but not millions of rows by any means. And we started looking at, okay, so why is your insert statement slow? And what we learned from that, they had a bunch of triggers on it. So we looked at the triggers to see if that was the problem. And none of the triggers were the issue. That was what they suspected at first. So then I looked at, well, what's blocking? When you do an insert to a table, it needs to get an exclusive lock in order to insert those rows into the table. But if you have another query running that's a select, that's a long running query that has a lock on that, a shared lock, then the insert is unable to get the exclusive lock. So in a normal situation where all your select statements are running really quick, it's not going to block your inserts. But this was a really long running query that was keeping the insert from happening. So what we found was the problem was not at all with the insert statement, but it was the query that was blocking that was causing the trouble. Well, I was kind of hoping that after we started this, that maybe a blocking query would show up here. And it hasn't, because this is my dev environment and I've tuned it pretty well. But what we're going to do, I'm going to force a blocking query. What I have here in Management Studio is my blocking test script, and it creates a table, throws 1,000 rows into that table. It opens a transaction, and then it updates all of those rows and then attempts to select from that. And I'm going to be one of those developers or testers or DBAs that gets a little bit sloppy and forgets to roll the transaction back at the end of it. You notice what I've got highlighted there when I run it? And either forgets to roll it back or forgets to commit it at the end. So I've run that one query, and it has a transaction open currently. But I look back over here, I'm not seeing any blocking showing up related to that yet. So what I need to do is I need to copy this part here in another window. And let's say I'm a different developer on a different server doing something similar. And let's just pretend I actually want to commit the transaction. When I run this, you'll notice in Management Studio, it's just doing an update and then a select and a commit, but it's stuck spinning at this point. And that would be the same as if this was a page on your website or in your application. It's just stuck waiting until this other query either commits or rolls back. But because I forgot to run the rollback, and we're pretending I just don't know what I'm doing there, it's going to stay blocking. Now, because of that, what we start seeing over here in the performance viewer is under the blocking queries, we get a list of this here. And when I click on this, it shows down below the block amount. And let me tell you what that block amount means. It just, when I clicked it, it was at 6. Now it's at 8. It's running about every 7 or 8 seconds and checking and counting how many are currently blocked right now. And it's using, in this case, it's the one blocker and the other query that's blocked, which is a total of 2 queries. And so it increases the block amount by 2. Now, on a crazy system where you have like 100 queries being blocked, well, this number could go up really, really fast. When we look at it, we can see from the performance viewer, and we'll just pretend that you'd never seen me in the Management Studio running those queries. You'd be able to see, well, here's what's going on. Somebody's doing this work on this table. We can see from here, here's the user. I'm logged in with the Windows credentials who's causing the blocking. If you're a DBA and you look at this and this is somebody that really shouldn't be working in your database, well, that's where you have to go chase them down and ask them, why are you doing this? Or it might be as simple as using that test user to figure out, well, what system is it coming from? And this is a bit of a malicious attempt here in the way I'm doing it, but in most of the time, it's not something malicious like that. It's more just, here's a query that's a little bit slow. And because that query is slow, it causes blocking for other things to run. So this tool here, using that blocking option, gives me what I need to be able to go and track this down and do what I can to clear the blocking. Let's say I didn't know this was me in the Management Studio over here, and I could look and say, okay, well, right here, the blocker is 93, and I could just go open a Management Studio connection on my own and kill that connection, and it would clear up the blocking and allow you to continue on. But most of the time, what happens is it's not a sort of a fake blocking, like well, not fake, but a contrived blocking like we've done here, where it's just because of an open transaction. Most of the time, what you're going to find is you're going to find that there's a slow query in here that's the blocker. And the way you're going to fix it is to go figure out, how do I track down that slow query? And how do I figure out how to make it faster so that we can figure out how to, well, so it's not blocking as much. Lots of queries running on your SQL Server is not an issue. But when you have lots of queries that are hitting blocking, that's when things become an issue, because once somebody blocks, let's say it's a select statement that's blocking an insert, then I run a select statement after that. Well, now my select statement is going to be blocked behind that insert, and then 15 other people run other statements. Suddenly we have a really big blocking tree there, where it's one query that's now blocking 15 to 20 or 30 or 50 queries. And that's the point you get to when people describe it as my SQL Server is just stuck or hung or not responsive. That's how we catch the blocking. This is a program that, with the performance viewer, I generally will let this run for a few hours, or I'll let it run overnight, but it's generally not an application that I would let run day after day after day. That would be something different that we'd want to take a look at. But for someone describing there's a problem right now where the SQL Server is not responsive, or if you see that every day around a certain time that it gets slowed down, this is a great tool to track that down. So here, every time we click on the different things, it updates the window down below with the details. If we wanted to look at the indexes that were suggested and see how they relate to the queries we have below, you can get that just by clicking on the side over here, where we can click and see the cost. Now, the cost numbers associated with indexes are what we get from SQL Server as to the cost associated with queries that would have been helped by this, and that's execution plan cost that we're talking about there. These are pretty small numbers because it's a pretty tuned system I have, but like in the example I was talking about yesterday, it started out and pretty soon we had cost numbers of 20,000, 30,000, 40,000 that were racking up here. And we looked at those top indexes that were needed at that point. And by clicking on the different ones, you can see the create script down below. We were able to do quite a bit of tuning just by finding those indexes, considering if they were useful and then adding them, and then finding the queries that were slow and doing what we could to speed them up. This tool, the Performance Viewer, is part of Database Health Monitor, and I think it's one of the most valuable pieces to use when you're trying to track down something that's stuck or blocked, or why are things running so much slower right now than they were under normal conditions. Now, another thing we have in here is we can hit the reports button and either run the blocking query report or the missing indexes report or the full report. And what that does, it takes it and just formats it over here and in a different format that lists off all of the blocking queries details and all of the missing indexes details. And I usually will go in here, highlight the whole thing, and copy that and then paste it off to a Word document when I'm working with a client. And then I'll email them that Word document, or we'll review it together and figure out how can we work to clear up the issues that are causing the blocking or the missing indexes here. One of the reasons I have the connections up top here, this little chart that keeps ticking away, is that oftentimes when you see excessive blocking, it starts clogging up the system and people keep hitting refresh in their browser or attempting to run the query again. And that just causes more and more connections to be backlogged or clogged up, waiting for things to happen. So that connections chart across the top really just gives you the ability to see if we're running at a baseline level, like we have been here between like 60 and 80 on my computer. If you suddenly see that starting to increase and increase, then that's a sign that things are blocking and that web pages or applications are just asking for more and more connections because all the connections they have are clogged up, blocked, waiting for things to finish. Now you notice here this blocking amount of 78, which is just increased to 80 there, it just keeps increasing over time as long as that's blocking. What I'm going to do is go back over here to the problem when query, and I'm just going to roll back that transaction. And as soon as I roll that back, the query in the other window finishes. And that took 7 minutes and 36 seconds to finish. But at this point, our block amount, which is at 80 right now, is going to stay at 80. It's not going to increase anymore until that same query shows up there. This specific performance viewer as part of Database Health Monitor, I have used on a lot of big environments where clients have had perhaps their biggest expected sales day or some type of an event or something that was going to cause them to have far more traffic than they've ever seen. And by using this, I was able to track down either missing indexes that would help that when things went bad, we could apply those to prevent things from being slow again, or we could find the blocking queries. And sometimes it was as simple as killing the one blocking query that was the problem. Other times it was we had to go in and performance tune it and clear things up. It really depends if that blocking query is an ad hoc query like the one I ran in the browser, or if it's a query that's coming from some page in your application. That performance viewer was something that I added to Database Health Monitor in 2022. Quick review, I'll close it out now, but where you get to it, you can get to it from Tools, SQL Performance Monitor, or by right-clicking on an instance in Database Health Monitor and choosing SQL Performance Monitor here. You'll get connected, and then Oh, it's on the other screen. And then once you start it up, you just hit the start monitor and it just starts collecting data here over time. It's fine to let it run for an hour or 2 hours or 3 hours. Even on a real busy server, it's fine to let it run, because what it's doing is it's a pretty light load. It's just saying every second, it's saying how many connections are there and what's the CPU. Every 7 or 8 seconds, it's just asking for the blocking queries. And then every 30 seconds, it's asking for the missing indexes and logging that. That is the performance viewer. I guess before I move on to the next item, any questions about the SQL performance viewer there before I move on?
Yes, Steven, not a question, but just information I want to ask that. The performance viewer you was showing that there are reports. So are you reading the DMVs in backend?
So everything that Database Health Monitor does is either running queries or reading DMVs. And
Yes,
I mean,
okay.
that's how we get all the data. So when we run the performance viewer and connect to a database, and I mean, the way it gets all the data is either from queries or DMVs. And I mean,
Got it.
there's no like secret sauce to where that comes from. Though it's just the how it's all built out that is the combination of really kind of what adds the value there.
Yeah.
So, and the way it used to be before I built this is I would open up like 5 different versions of Database Health Monitor. I'd have one here running on our what is active report, and I would use the hotkey F5 to refresh it here and there. And then I would go back and I would have another one that was open on the blocking queries page we have, and I would keep refreshing that. And then I would have another query that was open showing different user connections, and like here, connections for the total count of connections, or I would also be watching our total connections down here at the bottom where it shows 74. And really what I did is I just collected up all those different individual report data and built it into this one application that gives me what I need to track those key items on the SQL Server when performance is going on. The next thing I want to take a look at here is our historic weights report. You can see on this SQL Server, there's these blue bars across the top. If I click on this other one, you can see that it's not yet configured. What you would do is you would click there and you would use the current instance for monitoring. And what that does, it sets up a SQL agent job and a monitoring database on that server. We're not going to do it on that one right now because I already have it configured over here. And then it tracks information as what's going on over time. Here's a side note that's really interesting as we look at the performance here. On February 3rd and February 4th, I have this is my development desktop, my home office. I have a RAID 10 array that I use for, not for my boot disk, but for my data files and all that. And if you're familiar with RAID 10, it's striped and mirrored. And I had a disk failure in one of the 4 drives in that RAID 10 setup on the 2nd, and I wasn't able to get the replacement disk until the 5th. Between that time frame, I had some pretty degraded service running on that RAID array with one of the disks in a failed mode. Didn't lose any data, but it was just slow running in that degraded mode. So if we look here, we can see over time when we look at these charts of weights, and this is looking at SQL Server weight stats, which if you're not familiar with SQL Server weight stats, every time SQL Server is working to do anything and it's stuck waiting on something, it logs that as a specific weight stat. So for instance, if it's waiting on memory allocation, it logs that. If it's waiting on IO, it logs that. If it's waiting on a write to a log file, it logs that, or parallelism, things like that. What I'm looking at here, though, is we can see on February 3rd and February 4th, there was an unusual spike here, way out of the ordinary. And if we go back 2 weeks or even 1 month, I mean, there's never been a spike of weights on my system like that before, because the databases were running, and these are test databases, of course, so there wasn't any concern over real data, but the test databases were running off of a failed disk that was running much slower than it should have been running. And when we look here, we can double click and see, well, the biggest query that was having issues was a stored procedure called update issues history. and it was having problems with CX packet and CX consumer. Normally, when you see CX packet and CX consumer, you assume, well, if we double click on CX packet here, it'll tell us some things, but you can assume things like MaxStop, or if we click here, we can bring up some more help on CX packet that talks about the common things around CX packet are maybe you've got missing indexes, CPU pressure, memory pressure, out of date statistics. I mean, these are all the things you would normally chase to go find out why it has CX packet weights. But one of them that's the abnormal thing that CX packet weights is if your IO is extremely degraded because you're running on a failed array, like I was at that point, it takes a lot longer. So CX packet is saying that a query has gone parallel and it's running on multiple cores, and it takes longer for all that data to come back. So there's a whole lot of time that it's waiting for things to complete before it returns that query. And the waiting is not caused by any of these normal things on this specific environment. It's caused because I had a failed drive that was very degraded at that point. But let's jump back here and put this to 2 weeks, and we'll look at kind of a more realistic environment where we didn't have a failed disk. So here we can look at these different days and see that, let's go a little bit further back here. Okay, so here's a pretty typical week where there was a spike on December 31st, but January 1st and on, everything's kind of a constant pattern there. And usually when I'm looking at the historic weights, when I see a constant pattern or an occasional spike like this, and it goes away the next day, that's not out of the ordinary. What I'm looking at is kind of the trend over time. And when you see the trend, there's nothing that ordinary but let's look at what was going on 12/31. Well, on 12/31, somewhere around 3 a.m., there was a lot of weights associated with an SPOA method call. Oops, I clicked the wrong one. And if we double click on that, we can see what the SPOA method is used for in this specific case is it's used to do a web service request. And this specific web service request, the site that it was requesting from was down. So I know that this specific time, that's explainable as to why there was a problem at 3 to 4 a.m. on December 31st, because that specific site it was trying to talk to was down. So that kind of rules that out as something I would chase to improve performance. Then I'd look next at, okay, well, the next one here is DBCC CheckDB. Well, it varies on time depending on load and other things on the SQL server. But what we're seeing here is that CheckDB takes a fair amount of time. And if you're familiar with CheckDB, or if you're not, what it does is it goes out and it scans your entire database. Well, that's something that is usually not a big deal because you've usually got it scheduled at a time that there's not any issues going. I mean, that there's not a lot of load. And an important thing is it does take a lot of weights. Because this is my test environment and I have maintenance jobs and things like that running, I don't have a lot of real queries running. But here we look at something like this query, delete outliers. Well, this is something that we can see over time, January 11th, January 13th, January 19th, that this is something that increased over time. And as we got up to around February 2nd or so, it kept getting slower and slower and slower based off of parallelism. And I think that may have been related to the point in time where my drive was starting to fail on my RAID array. Perhaps my RAID array has thrown off some of the real data here. What I'm normally looking at here, let's just go back. So once it's enabled, we're looking at this. And then if we zoom in on something like one day, here's today, and we can see that today in the 9 a.m. hour, and I'm going to click on 9 a.m., that we had blocking specifically from 9:13 my time up until about 9:20. When you see something like this where it's stacked bars that you can continue to grow and grow and grow over time, that usually means that it's the same thing that's stuck and the weights associated with it are just starting to pile up. So in this case, this was our blocking test. We can click on it and see, well, what was it waiting on? Well, it was waiting on a lock in order to be able to do the update. When we ran the performance viewer and we caught the blocking query, that showed us what the culprit was or what the blocker was. This is showing us who the victim is or who is actually waiting on that other query. Using a combination of the historic weights to track over time what's going on at specific times, along with the SQL Performance Viewer, you can kind of get two different views as to why something might be slow on your database, from what's blocking versus on the other side, what is being blocked or what is being slowed down because of that block.